Okay, hi everyone, and good afternoon. I am Mano from Keysight, and I'm joined by Kamal today. I know our topic says T2 chassis, yeah, but overall, like we are going to cover a little bit in general on what we have enabled Sonic in terms of testing from our side. Without further ado, I think we're going to a little bit touch upon why RDMA is critical, and I'm sure the folks in the room, you guys are pretty familiar with why RDMA is critical for Sonic. And our testing journey as far as RDMA is concerned, but also at the end, we'll also talk about a little bit what we are doing as a next step. We'll definitely talk about a little bit about the collaboration with the community. We have been working with many vendors and especially with all the cloud service providers involved in Sonic. And we have been privileged to do that. And we'll talk about a little bit on when we started porting these test cases from the T1, T0 to T2, what are the multi-ASIC challenges that we have faced so far. And finally, we'll go to where you can find all this information. This is all in GitHub, so we can give you all that information and some next steps and call to action. So obviously, when we look at the definition of Sonic in the website, we highlight two key aspects that Sonic wants to focus on. One is BGP, one is RDMA. And today's talk, we are mostly focusing on RDMA, but our testing is kind of obviously spans across all the different aspects of Sonic and including BGP. We are going to talk a little bit on what we are doing on BGP and as a next step. So as far as RDMA is concerned, we all know that's the main motivation of enabling RDMA on Sonic is to have congestion control, having lossless fabric. And we wanted to do it through a commodity Ethernet solution. We know there are other competing solutions to prevent congestion in a data center, but obviously doing it through a commodity Ethernet enables us to expand a lot. And the main couple of things that we have been testing so far in the RDMA area are the PFC, the Priority Flow Control, and ECN. And we're also going to talk a little bit about how we have tested PFC Watchdog. But as a next step, I think we are also enabled and we have started a conversation on how we can bring this up to the next level, taking Rocky V2, DCQCN kind of scenarios, and to enable the future of data center coming into AI. And hopefully that's where Sonic is also going, and we are already in collaboration and conversation with different other partners to how to enable this testing in Sonic as well. A little bit look on how this has evolved from 2019. I think it was, if I have my chronology right, so I think we started getting involved in the Sonic community back in 2019, 2020s. And we started looking at the existing test bed, which was PTF, and there were some, it was great. I mean, there was a lot of test cases available, a lot of control plane and functional testing available. But there was some lack of testing in terms of how we enable line rate traffic generation, how we create these congestion scenarios, right? So that's where we came in and as a first step, we integrated some of the traffic generators, like the high-speed traffic generators, including 100 gig, 400 gig, 800 gig, and we are already working on 1.6 tera. And we also enabled how to test features like priority flow control, how to create congestion, test the lossless, lossy traffic, how to do PFC storms, etc. And then, obviously, some of the test areas that we talked about earlier were the PFC, ECN, and PFC Watchdog. You can find these test cases in GitHub, and it was done in collaboration with Microsoft. And thanks, and big shout out to the team for helping us build this whole test framework. And now these test cases are standardized and available to the community to leverage from. And we have already tested multiple vendors, so these tests are pretty much vendor agnostic. So and it's already part of the nightly Sonic regression. So we always look at the results. Any one line code change breaks anything, we address that. And now, finally, at this stage of from 2023 end to 2024, we have been talking to the Sonic T2 chassis group, and we are working closely how to migrate this test over to T2. And that's where a lot of our talk will kind of focus today. So with that, I will bring in Kamal, who will go through a little bit on the details on what the testing has been so far.
So in the year 2020, we started collaborating with Microsoft and developed cases on RDMA. So these are the cases which we have developed as part of RDMA. It includes PFC, ECN, and PFC watchdog. Under PFC, we have cases to validate the behavior of lossless and lossy traffic profiles by sending PFC positron from the receiving end. In addition, we have cases to measure the PFC response time and also the headroom. Under ECN, we have cases to measure the marking probability and the egress marking. Under PFC watchdog, we create different traffic patterns and then send PFC positron from the receiving end and validate the behavior of the PFC watchdog. So this is the testbed which we have used for running these cases. It includes a testbed server where the ASICs network and the sonic management dockers will be running, which in turn is connected to the Keysight chassis and the sonic DUT. Ports are interconnected between the chassis and the DUT. And these are the two topologies which we have used for running these cases. So coming to the methodology, let's look at one of the PFC use case. Here we have a transmitting and a receiving port which is connected to the sonic DUT. We will be creating lossless and lossy traffic profiles and we will be sending from the transmitting to the receiving side. Depending on the test case, like the data traffic can be a lossless or lossy. So in this case, let's assume that the data traffic is carrying lossless traffic profile with priorities 3 and 4. And the background traffic will be carrying the lossy traffic with priorities 0 to 2 and 5 to 6. So initially, when there is no congestion, all the traffic will be received at the receiving end. So in order to simulate the congestion scenario, we will be creating PFC positron and will be sending continuously with priorities 3 and 4. So once the transmitting side will receive this PFC positrons, it will stop transmitting the packets. So using this methodology is applicable to all those remaining cases, whatever we have developed. And we have developed using ASIC network and Snappy. And all these cases are already integrated into the sonic management. So these are the links for the test cases and test plans. Here we can see, I'm not sure whether it's visible, but under Snappy test, these are all the set of cases which are supported by the Keysight hardware. And there are in total like 107 cases, which can be run on 100 gig and 400 gig speed modes. And all these are part of sonic regression runs. Later, requirement came in to enhance these RDMA cases to support the T2 chassis. And the testbed used is similar to that of the T0, T1. Here we have additional connections. So here we have connections to the multiple DUTs. Here the sonic DUTs represents the line card of a T2 chassis. The users have the choice to specify on which line card or which ASIC or like that. So that can be specified under the variables file. So depending on the user input, the ports will be picked and the test will be run. In addition to these RDMA cases, we have developed like congestion scenarios as well. So in earlier cases, we will be sending the PFC positron explicitly, whereas in case of congestion scenarios, we will be congesting the egress port so that will be sending back the PFC pos frames to the transmitting side. So let's look at one of the PFC congestion scenario. So depending on the user input, like the ports will be selected here. So in this case, let's assume like we have selected ports from 2 line cards, and in this we have 2 ingress port and 1 egress ports. Initially, we will be sending lossy traffic profile with priorities 0 to 2 and 5 to 6 with 25% of bandwidth from each ingress port. As there won't be any congestion, all this traffic will be received at the egress side. And later, we will be creating lossless traffic profile with priorities 3 and 4 and 30% of the bandwidth each. So this will be oversubscribing the egress port, right? So that port will be sending PFC pause frames to the transmitting side to reduce the incoming rate. So the incoming ports will be reducing the rate so that there won't be any more congestion on the egress side. After that, all the traffic will be received on the egress port. So one of the main challenge was to get the T2 chassis in-house. So we had to collaborate with one of the Sony community member in order to test all these cases. So these are some of the defects which we have found while testing these RDMA cases. I won't be going in detail much, but these are just to highlight some of them, like some incorrect flows and then PFC watchdog timers. We have to adjust those timers. So these kinds of issues we have found. And these are the links for the test bed and test cases. Under Snappy Test and Multi-Dart, these are all the cases which are supported for T2 chassis. And these are the pending PRs for the congestion scenarios which we have mentioned. So these are the cases which will be pending for to merge.
Oh, okay.
Yep.
Yeah, thanks, Kamal. A lot of content there. I think when we share these slides, you can go through the links. There are a lot of links in there embedded. But obviously, we are working on a lot of next steps. So I just wanted to quickly take a moment to acknowledge that. So as Kamal showed, there are a bunch of incoming pipeline of PRs that are coming in on the T2 chassis side. We have not stopped our work on T1, T0. We are still continuing contributing in areas of other than RDMA as well. One of the things that we are working in collaboration with Microsoft again, and on the right-hand side, you see the screenshot of the test plan. I'm happy to share that, the link to this as well. Kamal and Deepak from Microsoft has co-authored this. I think there was a presentation in chassis subgroup last month to go over this. We still are working on automating these test cases. But this covers a lot of these complex data center convergence scenarios related to BGP. So we are emulating a lot of these incoming inbound and outbound traffic scenarios, including the convergence scenarios like any line card failure, BGP flaps, and also some of the planned events like TSA and TSB. So these are some of the emulations that we are doing on our side and testing the chassis, how it behaves, what's the convergence time, how's the performance. We also are doing some end-to-end route performance test cases. I know this, the Sonic routing work group has done a lot of work in this area as well. So we are, obviously, we can emulate millions of routes from our end to kind of pump into the device and do some math there as well. So that's also one of the areas that we are working on. So overall, there's a lot of work right now focused on T2 because that's kind of the up-and-coming area that we are working on. And I think this is our final slide. So obviously, we have been collaborating a lot with the community, and we want to continue doing that. So please talk to us if you have any testing needs or anything that we can collaborate on. Review the RDMA areas that we talked about. We'll share the links with you and explore any new areas like Rocky V2, DCQC, and we want to start working with the Sonic community in these areas. And we've been working very closely with the test working group, and that has been our learning forum as well as a forum to exchange ideas with the Sonic community. So find us there if you are not able to reach us through any other means. And we always co-develop these test plans. We do not, like for an example, we do not develop these test plans in isolation. We always work with somebody in the who are actually deploying this feature or actually working on this feature. So we want to co-develop these test plans and methodology. And finally, we are here for the next 2 days, but if you want to drop us a note on any of these material that we have presented or any questions or comments, I have my email and Kamal's email in there. Okay, that's it we have, and any questions, welcome. Yeah, I think there's a question back there.
Feel free to shout out your questions too.
Jeff Tensur, NVIDIA. question, a couple of comments. So comment number one, when you oversubscribe, you definitely want to separate traffic that marks 48 from other lossy flows. So you don't want to drop BGP, right? So 3, 4, 6, 7, and then 0, 1. The queues are different, have different priorities, different configuration. I happen to be familiar with configuration. So please treat control plane separately from the rest of lossy traffic in your tests.
I didn't get, go ahead.
Yeah, by default, 3 and 4 are the lossless, and remaining are 0 to 2, and 1 to 6 means 5 to 6 are the lossy ones.
Sure, but again, control plane should be tested separately from the rest of lossy traffic, specifically BGP marked packets.
I think he's asking to create a high priority queue
For,
that is lossy but separate.
so for that.
So you don't want to see them being dropped randomly, right? It should be priority. Question with regards to, so you've been testing traffic that is southbound to tier 2. I would be really interested to see northbound, so when you go outside of data center, where your latency is in milliseconds, not microseconds anymore. So if you plan this, I would really be interested in this.
Yeah.
And last question with regards to testing of PFC watchdogs. They've been implemented. It's important to see that they work properly.
Yeah, it's already implemented and integrated. Yeah.
Yeah, so for just answering the northbound and southbound, so we definitely have that in the plan. So if you saw that inbound and outbound scenarios that we are doing for T2 chassis, the test methodologies are typically agnostic of which topology you want to run on, right? So because at the end, it's us, like in the traffic generator side, it's not, we do not like care about what's inside, right? So we can always look into like the traffic generator test cases can obviously be migrated across topologies. And that's why you see a lot of these T1, T0 scenarios are kind of coming into T2 seamlessly. Well, when I say seamlessly, a lot of work is being done on the sonic side to configure it properly rather than changing the stuff on the traffic generator, right? So that's why like the inbound, outbound topologies that we develop in T2 can obviously go back into T1 and T0 as well. Sorry, I can.
When you go from Q2 towards RNG or outside of data center, the latency is high, so your transport is not going to work. Your congestion control needs to be different.
Right.
That's very important.
Absolutely.
Yep.
Yeah. Any other questions?
So your testing of ECN and PFC covers Rocky V2. So when you mentioned that explore new areas like Rocky V2, what other kind of testing do you mean?
So good question. So right now it's basically limited to PFC and ECN, not to Rocky V2, like not doing a stateful Rocky V2 as such, right? So the next stage would be to do the DCQCN, the Q pairs, those kind of testing are the ones that we are coming up with, right? So that's building the next layer out of PFC and ECN.
Hi, Dave Maltz, Microsoft. So as you were applying those test cases, you came up with some very nice issues you found in RCA style. What kind of outputs are you getting from your test that would help someone get from this test failed to that root cause analysis? Could you tell us a little bit more about the telemetry monitoring, or is there any sort of wizard RCA type decomposition built into the test already?
Right. So I think a lot of this happened during when we were doing the T1, T0, and I think we worked at that time with Weibai and also a lot of Mellanox folks joining the calls together. So we did a lot of these RCAs jointly, right? And the good thing is, since these are kind of standardized tests, so if you are going from vendor to vendor and different platforms, you kind of expect the same results. So it's kind of, you don't have to kind of tune the test cases per vendor, right? So that's where the beauty of these test cases lie, and that's where the RCA is very helpful, right? And we discovered a lot of issues going through those cycles, right? And also we saw a lot of ASIC dependencies, right? So definitely when we cut across different ASICs, and we saw a lot of dependency there. And also when we cut across different switch platforms, most of the issues, I would say, were ASIC dependencies, right? There were a lot of tuning that needs to be done there.
Yes, since we go into the AI fabric, so RDMA is very important. But the one headache I have is like we don't have enough GPUs to test in the high scale for the AI fabric. So I'm wondering, will you be able to go one step further to go from RDMA up to the nickel level or those things to generate more traffic?
Very good question. Thanks for asking that. So definitely we are looking at that. We have solutions that are emulating GPUs. We understand the cost barrier to kind of have so many GPUs to test that fabric. So we exactly have that solution. I don't want to like make this a marketing pitch here, but let's talk one-on-one. I can share materials with you. It's already in the website. You can find more information, but we definitely can share more information. But exactly that's what we are trying to do, and we have already solutions in that area.
I got a question follow his. How many GPU in your mind you want to test or you plan to test?
So how many GPUs? I think I would flip the question a little bit here. So basically the testing that we are currently mostly focusing on is how to test the fabric, right? And us emulating some of the GPUs, right? So we, yeah, I see Venkat standing up there, so he can add some more comments. But yes, that's kind of our focus area to kind of flip it around a little bit. So I'll let Venkat comment as well.
Right. People are, every time we think we are happy with the fabric, they're building bigger fabrics. Right? People are talking about 25,000 is just the basics, right? So the only way we will scale is to really combine simulation, emulation, and real. Right? There's no other way, right? Unless you really have deep budgets to pay for some of the friends here, right? So I think the architecture in the long run is evolving towards, take a set of real, GPU-based servers and run real applications, and then kind of do some emulation and make sure the fidelity, you're happy with the fidelity. If you're consistently off by 3%, that's good. You can kind of depend on that, right? And then even there, simulation versus emulation. The way I will, everyone has their own definition. I would say simulation is a lower fidelity emulation where you don't want to debug. It acts like a duck and quacks like a duck, so you're okay to kind of, cover certain scale of adjacencies or certain scale of certain behaviors behind in simulation, right? Going back to give some numbers, we are building 64 node, 128 node typically, because when you're doing testing, you don't want to, unless, like I said, you have lots of budgets, people are not building bigger networks than that for testing. But the idea is to, if you have one ASIC pre-silicon, you want to kind of surround it with 15 other emulated silicons, right? And if you have a box with 8 GPUs, then you would want it to emulate maybe 5 to 10 boxes around it. It's always like, at a rough math is that 1 to 16. If you have one rack, you want to make it look like a 16 rack test bed. That's the next scale you would want to get to with emulation, right? I don't know if that answers.